Here we have a SAT math problem. Okay, let's go to the question. In the figure above, AD equals to 4, BD equals to 3. What is the value of sine C? Okay, here in the given figure, we have to get the value of the trigonometric ratio sine of C. See, here we have the vertex C. So we have to consider the interior angle measure of the vertex C. Okay, now let's consider the right triangle ABC over here. In this right triangle, so considering this interior angle measure, we have to consider this AB as opposite side, and we have to consider this AC as hypotenuse because it is opposite to the right angle, and the third leg over here AC is adjacent side. Okay, now to get the value of sine C, we have to use a formula according to Secreto, that is opposite side divided by hypotenuse. Okay, here consider this interior angle measure. AB is the opposite side. I don't have the length of the opposite side, and also I don't have the length of hypotenuse as well, because for the hypotenuse we have the part of the length, that is 3. I don't have the length for this CD. Okay, and also in this right triangle ADC over here, if I have the length of this leg AC, I can use Pythagorean theorem and get the length of CD, but I don't have length for AC as well. Okay, how do you have to solve this problem? Okay, here let me consider two right triangles over here in the given figure. There is a smaller right triangle ABD over here. Actually, it is a right triangle because here we have right angle. Okay, and also let me consider the bigger right triangle. That is a complete right triangle ABC over here. Okay, now when I consider these two right triangles, apart from the right angle, we have a common vertex B for both the triangles. In any two right triangles, apart from the right angles, when we have common vertex, then we have to consider the two right triangles as similar right triangles. Okay, here this right triangle, the smaller right triangle ABD and the bigger right triangle ABC are similar because both of them are right triangles, and also they have the common vertex B. Okay, now let me write the similarity statement and let me consider the vertices of the bigger triangles first. Okay, now let me take the vertex A in the bigger triangle. So because here we have a right angle, and now we have to get the corresponding vertex in the smaller right triangle. We have to consider the vertex at where we have the right angle, that is D. Okay, now let me consider the vertex B. It's a common vertex for both the triangles, and the third vertex for the bigger triangle is C, and the third vertex for the smaller triangle over here is A. Here, these two triangles are similar. Now let me consider the vertex C in the bigger right triangle ABC. What is the corresponding vertex in the smaller right triangle DBA? That is A. Because we have to consider the letters at the same position. Okay, if two triangles are similar, then the corresponding vertices will have equal angle measure. Now let me consider the interior angle measure of the vertex C over here in the bigger right triangle. And also let me consider the interior angle measure of the vertex A in the smaller right triangle DBA. It is over here. So this interior angle measure and this interior angle measure must be equal, because in these two similar right triangles, so the vertex C and the vertex A are corresponding vertices. Okay, now let me consider the smaller right triangle DBA over here. Actually, in this smaller right triangle DBA, AB is the hypotenuse because it is opposite to the right angle, and for the remaining two legs, we have the lengths 3, 4. Then it is 3, 4, 5 right triangle. That is, in a right triangle, if two legs are having the lengths 3 and 4, then the length of the hypotenuse has to be 5. Otherwise, we can use Pythagorean theorem to get the length of the hypotenuse over here. Okay, now let's find the value of the trigonometric ratio sine of this interior angle measure at the vertex A in this smaller right triangle DBA. So that is sine A equals to, the formula is opposite side divided by hypotenuse. Okay, here considering this interior angle measure at the vertex A, the side BD is the opposite side because this is a side opposite to this interior angle measure, and we know that AB is hypotenuse because it is opposite to the right angle over here. Okay, now we can plug in this 3 for opposite side and 5 for hypotenuse over here. Then I'm getting 3 over 5. Okay, here in this smaller right triangle DBA, I got the value of sine A. Already we know that interior angle measure at the vertex A in this smaller right triangle, interior angle measure at vertex A of the bigger right triangle are equal because they are corresponding vertices. In two similar right triangles, the values of a trigonometric ratio at the corresponding vertices must be equal. So the value of the trigonometric ratio sine at the vertex A in this smaller right triangle DBA must be equal to the value of the trigonometric ratio sine at the vertex C of the bigger right triangle ABC. So then the value of sine C equals to the same value, 3 over 5. Okay, here I got the value of sine C. It is 3 over 5.